I'm Anil Kumar. Welcome to my series on factors and multiples. We have 15 questions in this particular video. I would like you to copy these questions, answer them, and then look into my suggestions. Now let us try to understand and see these questions first, and then we are going to answer them. Question number 1 here is, we are given a list of numbers 1, 2, 3, 9, 12, 27, 25, 30, 36, 91 and 99. Using the numbers in the list, write down about this, right? Write down all prime numbers, all composite numbers, all even numbers and all square numbers, right? So that is the first exercise. So you need to identify the prime numbers given in the list, the composite numbers given in the list, even numbers given in the list, and the square numbers given in the list. Write them down, right? So that is how it will work. Then we have another question which is similar to this. Again, there is a list of numbers and you need to identify factors of 24, multiples of 4, odd numbers, and cube numbers. Now, while you do all this exercise, there will be few things which you might have forgotten and you might recall. So you can actually look into your notes and then answer these questions. And then you can also see my video for the final solution. Question number 3. We have list of numbers as in previous two questions. And this time you need to write multiples of 3, multiples of 9, prime numbers, and numbers not included in the above list, right? Question number 4. Another set of numbers given in the form of a list. You have to use all these numbers to answer these 4 questions. Multiple of 7, a factor of 21, 2 prime numbers, all multiples of 3, right? This is going to give you a good practice. That's the whole idea. Question number 5 is, work with the list given to you and using the numbers in the list, write down all. So actually, let's remove this. Write down a multiple of 7, a factor of 21, 2 prime numbers, and all multiples of 3. Perfect. Question number 6. You have a list here again. We have to work with these numbers. Using these numbers in the list, write down 2 numbers with sum of 63, a number divisible by 9, 2 numbers, factors of 27, all multiples of 7. So I hope you must have got good review of factors and multiples. Now here we have 5 questions which are slightly different. You need to explain if here you need to explain if the following statements are true or false, right? So they could be true, they could be false, but whatever, you need to explain them. Question number 6 is 2 to the power of 3 equal to 6? 1 is a prime number. Even numbers are not prime numbers. Multiple of 9 is also a multiple of 3. Product of 2 numbers is always odd numbers. Product of 2 odd numbers is always an odd number, right? Then we have 4 other questions. The question here is, explain why the following statements are wrong. All these statements are wrong. You need to explain why. Sum of 2 odd numbers is always an odd number. 2 to the power of 5 equals to 10. 91 is a prime number. Product of consecutive numbers is odd. Consecutive numbers are the numbers which come together like 2 and 3. The last question here is, n equals to 2 times 4 times 6. Find all the factors of the number n. Correct? So I hope you find this exercise interesting and useful. So you can now answer these questions and then look into my suggestions. Now all these questions have to be answered without calculator, right? So let's begin. Question number 1 here is, we are given a list of numbers. Using the numbers in the list, write down prime numbers, composite numbers, even numbers, and squares. Now what are prime numbers? Let's try to understand that also as we answer, right? So prime numbers have only two, let me write TW, two factors. I should actually write exactly two factors, right? So since we are looking for two factors, 1 is not a prime number. 1 has only one factor, which is 1, right? 2 is a prime number, right? Since 2 has two factors, 1 and number 2. So 2 is a prime number here, 3 is a prime number, 9 is not a prime number, 12, 27, 25, 30, 36, 91, 99 are not prime numbers. So those are the only two prime numbers in this list. Composite numbers. Now the numbers which are not prime except 1 will be composite numbers. So we have already taken care of these two. The others are composite numbers, so just write them. They have more than two factors, right? So the composite numbers are numbers which have more than two factors. Clear? So if they are not prime, they will be composite except for 1. So 1 is neither prime nor composite. So let me make a note here. So the note here is 1 is neither prime nor a composite number, right? Okay. So rest of the numbers I'll just copy from the list and we will get composite numbers, right? Now some of you might have mentioned 91 as a prime number. So you need to now work out why it is a composite number, okay? So let this be an exercise for you. See, even numbers. Even numbers are numbers which are divisible by 2. Or you can say they are multiples of 2. So all even numbers are multiples of 2. So we'll go in a sequence and all the even numbers are now being listed, correct? Now square number. So if I say 2 square, then we get 4. 4 is a square number. Now from the list, can you identify the square numbers? A critical number here, which is a square number, is the number 1. 1 square is 1, right? So 1 comes here as a square number, right? The other number is 3 square, which is 9. 9 is 3 square, right? Then we have 25, which is 5 square, right? So 36 is also a square number. 6 square is 36. So you have to be very careful when you pick up your numbers. So this exercise may seem to be simple, but still you can make mistakes. Now that is kind of important. So work carefully, okay? Now let's take question number 2. Question number 2, we again have a list of numbers. Using the numbers in the list, we need to write down factors of 24. Now factors means all the numbers which can divide 24 evenly, right? So what are those numbers? So from the list, 2 times 12 is 24, 3 times 8 is 24, 8 times 3 is 24, 12 times 2 is 24, and the number 24 itself. So any number which is greater than 24 cannot be factor. So we need not even look into it. Now we have to look into multiples of 4. So like 4, 8, 12, 16, those are the multiples of 4. So in this list, we see from left to right, we get across 8, 12, 22 is not a multiple, 20 is, and then 24. And then 28 is also a multiple, but 34 is not a multiple. 32 and 36 are the multiples. Odd numbers. In this list, the odd numbers are 3, 5, and that's it. Cube numbers. Now, cube number is like 1 cube, right? So 2 cube is 2 times 2 times 2, and that gives you 8. So the number 8 is a cube number. You get the idea, right? So we will write the number 8 from the list. Do we have any other cube number here? Well, no. So that is the only cube number in the list, number 8. Question number 3. List 1, 3, 8, 15, 27, 32, 63, and 72. Using the numbers in the list, write down all multiples of 3. So multiples of 3 will be 3, 15, 27. So how do you get multiples of 3? If you add 6 and 3, you get 9. You can divide it by 3. So that is a multiple of 3, right? So that is again a multiple of 3. Now, 72, 7 plus 2 is 9. So that can also go by 3, right? So you add. Now let's see multiple of 9. Well, rule is very similar. So the multiples of 9, numbers add to 9, like 72, 63, they add to 9, 27. 2 plus 7 is 9. So these are the multiples of 9. In the list, these are the only multiples of 9. So we'll write them as 27, 63, and 72. Prime numbers. Now you know what prime numbers are. So you can select prime numbers from this particular list. Well, do you find any? Well, there's only one number which is a prime number here, the number 3, right? All other numbers are composite numbers. Then we have numbers not included in the list. Well, we did not include 1. 3 has been included. We did not include 8, 5, 15, 27 has come there. 32 is left out, right? 63 we have taken up, and 72 also. So that is the end of this question, right? So do you see how we can answer them? Now, question number 4. Again, we have a list of numbers. 3, 23, 25, 32, 49, 51, 100. Using the numbers in the list, write down a multiple of 7. So 7's multiple, which one is a 7 multiple? 7 times 7 is 49. So 49 is a multiple of 7, a factor of 21. 21 times 1 is 21, and 3 times 7 is 21. So 3 is a factor of 21. 2 prime numbers. So one is of course 3. Let's look for another prime number in this list. 23 is the second prime number. All multiples of 3. So that is, we get 3, and then we get 49. No. 51. 5 plus 1 is 6. So that is how you answer this question. Question number 6. This time the list is 1, 7, 9, 14, 32, 49, 72, and 77. Using the numbers in the list, write down 2 numbers with sum of 63. A number divisible by 9. 2 numbers factors of 27. All multiples of 7. Correct? Okay. So 2 numbers that add to 63. This is a time-consuming question, and you have to be very careful. So 63. So the combination which I can look into is 9 plus 4 is 13. So this combination can work, right? So if you check, that is it. So the 2 numbers are 14 and 49. When you add them, you get 63. A number divisible by 9. Okay, so we know that is 9 is there, and then 9 times 8 is 72. So these are the 2 numbers. 2 numbers factors of 27. So factors of 27 will be 3 times 9 is 27, 1 times 27 is 27. So we have 1 and 9 as factors of 27. Then we have all the multiples of 7. Multiples of 7 are 7, 14, and then 49. 72 is not a multiple of 7, right? 77 is, right? So that is how we get the multiples of 7. Now we are into true or false question where we need to provide reason. So the question here is, explain if the following statements are true or false. So they could be true, they could be false. Is 2 to the power of 3 equals to 6? Well, when I say 2 cube, it means what? It means 2 times 2 times 2. That is 2 times 2, 4, 4 times 2, 8, right? So this statement is false, right? So we'll write false here, and the reason is that 2 cube is 8, not 6. 1 is a prime number. The statement is false since 1 has only one factor, not 2, right? So that is why it is not a prime number. Question 8. Even numbers are not prime numbers. This statement is also false since 2 is a prime number, right? And also even, correct? Question number 9. Multiple of 9 is also multiple of 3. That is true, right? So since 9 itself is 3 times 3, so a multiple of 9 will be a multiple of 3. So you can explain. It's very important to explain like this. Question 10 here is, product of two odd numbers is always odd number. Let's take an example. Like if I say 3 times 5, I do get 15, so it seems to be true, right? So this statement is true. If you want to get an even number, there should be at least 1, 2 to multiply with, or an even number to multiply with, correct? So product of two odd numbers will always be odd number. We are almost at the end. Now just 5 more questions to go. The question here is, explain why the following statements are wrong. Question number 11. Sum of two odd numbers is always an odd number. Well, you can give one example saying that two odd numbers do not add to odd numbers. For example, 5 is an odd number, and if I add 7 to it, I get 12, which is even. So that means this statement is wrong, and that's the reason. So let's provide reasons here. 2 to the power of 5 is 10. Well, it is wrong because if you multiply 2 by itself 5 times like this, it is not 2 times 5. It is this 2 times 2 times 2 times 2 times 2. So you put 5 2's together to multiply and you get 4, 8, 16, 32 as your answer. Is that clear? Now 91 is a prime number. It is not a prime number because it can be divided by some other number. The number which divides into it could be, see, 1 you get 3 times 7 is 21. So if you try 13 times 7, what do you get? 7 times 3 is 21, 2, and then you get 91. So 13 and 7 are factors of 91. Now since it has more than 2 factors, right, the other factors are 1 and 91, it is not a prime number, correct? Question number 14 here is, product of consecutive numbers is odd. So when we say consecutive numbers, we are talking numbers like 2 and 3, right? So if you multiply 2 and 3, you get 6, which is even, not odd. Well, the reason here is very clear, that alternate numbers are even, right? So alternate numbers are even. So when you multiply, you should get even. So product of consecutive numbers is not odd, but always even, correct? Okay. Now here is the very last question, question number 15. N is 2 times 4 times 6. Find all the factors of number n. Now this is a very interesting example. You could do it in many different ways. The easiest way for you is you can multiply them. So you get what? 2 times 4 is 8. 8 times 6 is 48, right? So you have 48. So what you can do now is you can find all the factors of 48. For example, 1 times 48 is 48, correct? So we get 1 set, right? So 2 times what? So half of 48 is 24, right? Can you divide by 3? Yes. 4 plus 8 is 12. So 3 times you get 3 times 1 is 3 and then 6, right? So that gives you 48. If you multiply by 4, divide by 4, 4, 2, 4, 1 and 2, 12 will give you 48. You cannot divide by 5, but you could divide by 6. 6 times 8 is 48, right? 7 times 7 is 49. So these are all the factors of 48. So that is how you could list all the factors of 48. Correct? So that is the best way of answering this question. I hope you found this list interesting and useful. So you kind of get a good review of factors, multiples and prime numbers with these examples. Feel free to write your comments, share your views, and if you have more questions, post them. Thanks for watching and all the best.